appreciate you all. This has been a great class. It's a great class for me. I really appreciate the hard work that all of you've put in. I can see that has paid off. Hard work does pay off, and you guys have worked hard. This first one is a graph, and you'll have to just be sure you put a parentheses around your 1/5 unless your calculator puts those little squares in there, to the xth power. So you grab your calculator, and this is a multiple choice question. So you'll just pick the right picture. Do you want to do 1 divided by 5 and raise it to the x power by using this caret key here? They'll put that little x up there. And the difference is that when it's a fraction, it goes down the other way. It still goes through the 0.01, but it goes the other direction. So that graph will look like this. Okay, don't waste time on it. It's a simple one to do. So is number 2. Graph f of x equals 2 to the x minus 1. Notice that's going to have some words with it. It'll say start with the graph of y equals blank to the x. So you want to put your base in there. Your base is 2. And then it says shift it, and it has blank 4 units. No, 1 unit. 1 unit. Is that right?
In the chat, if somebody...
Is that left or right on that?
Right. I mean,
well,
yeah,
let's see, right. It's -1, so it's opposite of what you think because it's up here in this little exponent.
Right.
So which way do we go? Right. Right, 1 unit. And then there's a graph for you to pick. Now, if we're going to shift it right over here is what happens. If you have to actually graph it, which we'll have to do on this number 3, then you'll have to pick the graphing tool, and we'll go over it when we do the graph on it. Number 3 is f of x equals 2 to the x plus 4 minus 2. What do we start with?
2 to the x.
Michael's, and it'll be a blank, and you put the 2 in there, and the x is already in there, so you don't have to put all those other extra things. It's just the 2 that you put it in there. Now we're going to shift where? This one is a 4 units. Which way do you shift for this one?
To the left 4.
Left. And then it's going to go down 2 units. Now remember on this that you select that little graph that looks like that on your toolkit. And when you do that, put in the normal 0, 1 that it goes through. And when you put your little graph right there on that 0, 1 spot, it'll make your exponential equation in there. It'll make your graph. But then this thing will drop down, and it'll have a box there. And it will ask you to select the shifts from the table. Those first ones are stretches and shrinks. Stretch and shrink. We haven't done any of those, so skip that part and go down to the ones that say left or right, which it'll say horizontal, and then it'll say vertical. So in this one, we want to go down 2, so you're coming over to -2. And in the horizontal one, you're going left 4, so you're going -4. Put those in there, and if you forget to put this little box down here, it will not give you the graph that you want. You will have, it says E when you look at it. If you don't change that E to the base of 2, it will not do it for you. So keep that in mind. So what's going to happen is this is going to shift left 4 and down 2. So this is the way the graph is going in through there. So when you put these shifts in there, it'll automatically make your curve. Any question about that? Just remember this little box down here. I noticed several of you forgot to put in the base. And when you leave it as E, it's really close, but it's
Dr.
not
Sullivan?
exactly.
On number 1, I put the y equals the parentheses 1/5 close parentheses and to the x power, and it just keeps saying error window range.
Okay. You probably have changed it for one of your graphs for logarithms. So
Okay.
go to Zoom, and number 6 is standard. You can hit the number 6 once you hit Zoom and see if you can get the picture then.
It came then. Thank you.
Mm-hmm. Well, you're welcome. Anytime your graph gets off like that, and it's because you've been in there graphing probably those logarithms, it's off a little bit. Okay, hit Zoom and 6 and it'll straighten it out. All right, let's look at number 4. I wrote this one out because it's one of those investment problems, and you have to use A equals P times 1 plus R over N. And I don't know that you're going to need this little formula sheet, but I would copy it off if I were you, because you might need it for the final anyway. I'd go ahead and copy that off and keep it handy. But I wrote these out for you as an example so you'll know which one to use. This is an investment problem. It's compounded quarterly, so I'm going to use an N of what if it's quarterly?
4.
So my N is 4. My interest, which is R, is going to be 6 1/2, but I have to change it to a decimal. What is the decimal for 6 1/2?
0.065.
0.065. And my principal for this one is 64,000. Okay, so that's what I'm going to do. And the first one's just wants the function for t years. So I'm going to put A equals 64,000 times 1 plus 0.065 over 4 to the 4t is the way that's going to look. Okay. Now they want you to actually figure out what this is inside here. So you end up with putting it into your little box that they want to put you to put it in as 1.01625 to the 4t. That is actually the answer they want you to put in.
Can you leave this up for a second?
I sure will. We've got to do each of the amounts anyway. So this one will have a part B, and they want you to find t equals 0, t equals 4, t equals 5, and t equals 10. So what you're doing is putting those 0, 4, 5, and 10 in there for t. That's a T right there. So that's what they want you to do there. So the A one, this first one here, is going to be 64,000 times 1.01625, and it's going to be 4 times 0 when you put it in. So when you put it in your calculator, you have 64,000 parentheses 1.01625, and you're raising it, and you can put the 4 times 0 up there. And if you do that, you can come back in a minute and put the others in there. Let's see what we get. We get 64,000. that's not going to be so surprising because this goes to 1 because that's 0. So that should be the answer. Now, I hope that you remember that you can hit second and the enter key, and it will put your problem back down in there. So you don't have to type that every time. Then you can just go backwards and put in where it says 0, 4, and hit enter. And you get 82830. Then you can do second and enter again, and it'll put it back. Go backwards and put in 5. And it will give you 88347. And then go second and enter again, and then go backwards and put in the 10. And it will give you the answer for the 10, 121956. Okay, everybody understand how to do that shortcut, and it's not going to take a lot of time. Just make sure you put this first one in correctly. If you don't put this one in correctly, all the others will be wrong. Okay, any questions on that? Okay, let's talk about Melissa and her birthday. Melissa's in every one of these. This is number 5. On Melissa's 6th birthday, she gets a $3,000 CD that earns 7% compounded quarterly. If the CD matures on her 10th birthday, how much will she have? So we need some things to know on here. Our principal is $3,000. And our rate of interest is 7%, so that's 0.07. And if it's compounded quarterly, that's 4 times. So I have a 4 times, and we need to know our T. How do we get our T?
Subtract the birthdays.
This is her 10th birthday that we have here when it matures, and it started on her 6th birthday. So that's going to be 4 years. So it's 4 times 4 up there. So you can put that in the calculator just like that to get your answer. 3,000 parentheses 1 plus 0.07 divided by 4 raised to the 4 times 4. See how that looks in the calculator? And then we
What
need
if it were to say semi-annually? Will it change on the test, or is it going to be the same way?
it's semi-annually, the n would change to 2.
Okay, just
If
making
it
sure.
said annually, the n would change to 1. But I can tell you on this one, they're going to say quarterly. They like to do quarterly. So our answer is 3959.79. Okay, any questions on that? That's Melissa and her birthday. Remember that you've got to subtract the birthday times. Sometimes it'll say 12. Sometimes she'll start on the 5th birthday. Depends. They're going to change either this number or this number or this number or this number, but probably it'll still say quarterly. That's the Melissa problem. Any questions? Okay. So now we get to this section on logs. And that's the problem. Log 100, log base 10 of 100. Well, there's all kinds of ways you can do it. This one's already based on log 10. If our base is already on log 10, we just can do log 100.
When it's ran like that, it doesn't say anything. They just want the value, correct?
I just want the value. What
But
is
if they
the
want it
value?
in standard form, it will say, correct?
I'm sorry, if they what?
Like if they want expanded form, it will say
Mhm.
it on the question. correct?
Yes, it'll say write it in expanded
Okay.
form, or it'll say, I think it usually says use sums and difference.
Okay.
That's what it'll do.
Okay. Thank you.
All right, now we could have done log 100 divided by log 10. Could have done that. That's that change of base rule, log 100 divided by log 10. We could have gone into math and gone down to logs. There's all kinds of ways to do this. There's that log base, and you could put in the 10 and then arrow over and put in the 100. So hopefully, at least you know at least one of those ways that you could do that to get the answer to. Any questions on that?
That's probably gonna be the best problem.
Yeah, these in here are not bad. On this one, remember that if these match, your answer is just the exponent. It's 2. Now, if you didn't know that, there's all kinds of ways you can do it. You can put this into log base 4 and put 4 squared in there, and it'll give you 2. You could do log 4 squared divided by log 4, and you would get 2. You could do 4 to the x equals 4 to the second, and then x is equal to 2 if you want to make it as an equation. There's just all kinds of ways to do it. What is easiest for you? Which way do you guys like to do that one?
I think crossing it out, if I just remember it.
You can just remember these match. You get whatever's left over. That's the easiest, probably. Okay, let's try number 8. Log base 8 of 2. Okay, let's do this one by change of base. If we do it by change of base, we'd have log 2 divided by log 8 if we do it that way. So log 2 divided by log 8. See what we get. We get 0.33333. What do you think we should do with that?
Turn
Change
into
it to a fraction.
Change it to a fraction. What do we get?
1/3.
1/3.
Mhm. Let's see. You could put it in the math and it'll give you that decimal as well. You could do 8 and make an X out here like we did when we did these. 8 to the x equals 2. That's changing it to exponential. This would be 2 to the 3x equals 2 to the first. 3x equals 1. X equals 1/3. So this is doing it using an equation. This one is change of base. Anybody have another way that you'd like to do it, that prefer to do it? You can use the math key and do it. All right, so hopefully everybody can do that. Now, log base 11 of 1 equals. So somebody do one of the ways and tell me what the answer is.
0.
That's right, it's 0. So make sure everybody can get 0 on that using one of those ways. You can do log 1 divided by log 11. You can put it in the math and put in the 11 and the 1. You can do 11 to the x equals 1. However you want to do it. Any questions on that? Okay, let's look at 10. Number 10 does have some directions. It says convert to logs. So you have 10 to the third equals 1,000. Now, I don't know how good you're doing on these, how well you're doing them, but these seem to be a little bit of a problem for you to remember how it works. But we were going to try to get it to some form where it has a little base down here and a log number here. And over here is going to be your exponent. That's the way that's going to look when I get through with it. So I'm going to write it as log. And what is my little base number going to end up being for this problem?
10.
10. What is my big log number going to be?
3.
1000.
It's 1000 goes there. That's where people get mixed up. Remember, logs are exponents. So if you're saying log of something, this is really an exponent that it's equal to over here. So your exponent comes down there. This number that's on this side is your big log number. You might want to keep one of these handy just to use when you get to this problem number 10. So you won't forget. And I know those are hard. I know those are hard to remember. Okay, let's look at number 11. Number 11 says convert to logs. And they start with E squared equals T. Now, since it says E, I probably don't want to use LOG. What would I rather use?
LN.
LN, and my base is T. My big log number is, my base is E. The big log number is T. And my little exponent comes down over here on this side. LNT equals 2. Then on 12, we're going to go the other way. Convert to exponential. And for some reason, I think this is a little easier for most people. Log base 3 of 4 equals 2. So we have the little number to the answer is the big log number. I don't know if that helps or not. Little
Does
number.
this say 3? Log 3? Okay.
Answer equals the big log number. So my little bitty number to the answer equals the big log number. Remember that 2 is going to be there on the end of that log because that's the exponent. And your base is 3. So the only one you really have to worry about is that 4. Okay, let's look at 13. Convert to exponential. See, these are going to go really fast if you know how to do them. 13 is see which one I did. Log base m of t equals negative x. Let's try that one. What's the base? M? M to the what?
Looks like Emma.
Negative x equals t. You might want to practice that one. Okay, number 14. Number 14, it says find LN 951.4. 4 decimal places. All right, so you grab your calculator, hit LN 951.4, and you want it to go to 4 decimal places. So that's 6.8579, it looks like, because there's a 3 behind the 9. Number 15 says use change of base. Log base 5 of 60. So in your calculator, you would do log 60 divided by log 5. So log 60, don't forget to close your parentheses, divided by log 5, and you get 2.5440. You see why it's 40 instead of 39? See that? Because it ends in a 5 there. It's 5, 4, 3, 9, 5. 5 is going to make that 9 go to a 10. And then the 3 will go to a 4. Okay, let me grab and make sure we have people here. Let's see, Selena. Did Selena come in? Margaret Davis.
I'm here.
Is that Selena or Margaret?
Margaret.
Okay, good deal, Margaret. Erica, is Erica in? How about Portia? Did Portia come in?
Portia's here.
Okay, good deal, Portia. How about Danielle? Danielle's having some situations in her life, like all of us do from time to time. She's having a struggle. Let's try 16. See, this is what it says. Whoever asked that question, express.
Did you get this? Did you get Shaquila?
I did get Shaquila. Thank you. Express as a sum. See how it says that? That lets you know that you want to expand it. And it gives you log base 5, and in parentheses it says 5 times 25. Now, because that's multiplied, then what you're going to do is change that to added. You're going to change it to an added log. So it's going to be log base 5 of 5 plus log base 5 of 25. And you do not simplify. Okay? This one does not want you to simplify. They want you to write it just like that, because this will simplify and so will that. You'll end up with a number. So you don't want to do that. You want to write it as a sum, just like that. Any questions? Okay, let's look at number 17. Number 17 says log base n of x to the 19th. Now, I think almost all of you know what to do with this problem because we had to do it so much when we were working those problems. You bring this 19 in the front, and it will say 19 log base n of x. That's all you're doing is bringing that 19 in the front. Number 18 says rewrite as a sum. Now this one might be a little harder for you because it has multiple things to do. You have x squared, y to the 4th, and z to the first. So we write it as a sum. These are all multiplied here. So my first step is going to be log base d of x squared. That's my first one there. Plus log base d of y to the 4th. That's that one. Plus, that's how we're doing it as a sum, log base d of z. And it has a 1 up there, so I don't have to do anything about that. Now then, I'm going to do one more step, and I'm going to bring these exponents out in front. So I'll have one more step. It will say 2 log base d of x plus 4 log base d of y plus log base d of z. Okay? Any questions on that one? All right, let's do 19. I hope this will be an easy chapter for you to make a good grade on. Some of you need to have a good grade on this test 4. So I'm hoping this will be your really good grade that you have. So just pay really close attention, and if you can, put this sheet close to you when you're doing your test and use it as a reference. So this one says sums and differences. So that means there must be something on the bottom for this one. So we have log base b, and we have p to the 4th, q to the 5th on the top, and we have an m to the 3rd and b to the 8th on the bottom. So they're all 4 just different variables, so we don't have to worry about combining like we had to do that on that one problem we had on homework where we had to combine there at the end. So let's expand this out and see what we get. We're going to have log base b of
Does it say m to the 8 or m to the 3? I can't really tell.
8. That's an 8 there. B
And
to
the
the
m,
8th,
the
m to the 3rd.
Okay, thank you.
You're welcome.
I don't know if it was my computer connection. I just couldn't tell.
Okay. All right, so log base b of p to the 4th plus, notice that's a plus because that's a product up there on the top, and it's on the top, so you want to do a plus. Q to the 5th. Now these things that are on the bottom are going to be the differences. Those are the ones that are on the bottom that will be differences. So it would be minus log base b of m to the 3rd. I'll try to write it bigger so you can see it. And then it's minus log base b of b to the 8th. Now look at that. That's that rule we used earlier. So we're going to end up with just 8 on that one. Okay, now bring all of those exponents to the front. Okay, so we end up with 4 log base b of p plus 5 log base b of q minus 3 log base b of m minus 8, because log base b of b equals 1. So when I bring that in the front, it's just going to be times 1. So that's my answer. Any questions on that one? How are we doing? Am I going too fast for you? Are you keeping up, or are you just not writing these down tonight, or what is the deal? Y'all aren't.
I'm writing this down for sure.
Okay, good. I see that, Sequela. Okay, number 20. Number 20 is simplify. It says simplify in the directions. And they have ln x squared plus 7x plus 10. And there's a minus ln x plus 5. So we have to go from expanded to contracted form. That's what we're going to have to do. So we write 1 ln and we put this one on the top, and because it's minus, this one goes on the bottom. So we have x squared plus 7x plus 10 over x plus 5. And I'm betting that's what's going to happen is that this is going to factor into something that has x minus 5 in it. So that's x plus 5. X plus 5 and x plus 2, I believe, over x plus 5. It's the way that factors. Let's see, 5 times 2 is 10. So if I add factors of 10 to get 7, it would be 5 and 2. then those common ones will cancel. So I just end up with ln x plus 2. And you can put a parentheses around it if you want to. Okay, 21 is just like that one. It says simplify. And they give you log, and it has a trinomial here. And it has a minus, so that means this other one's going to be on the bottom. So I'm going to rewrite it. X squared plus 3x minus 10 over x squared minus 25. And x squared minus 25 is a difference of two perfect squares. Let's see if I can factor 10 so that when I subtract, I get 3. Let's see. X plus 5, x minus 2, I think will work. And on the bottom, that difference of perfect squares will factor into x plus 5, x minus 5. Then my 2x plus 5s will cancel, so I'll have log x minus 2 in the top and x minus 5 in the bottom. Okay. 22 says solve for x. Now, this is where some of you are struggling a little bit, is what to do when you get to these. So put a star on this number 22. 6 to the 2x equals 216. What you have to ask yourself is 6 raised to some power equal to 216. Well, let's see. 6 times 6 is 36. We know that. Times 6. Let's try that. 216 it is. So 6 to the third power is 216. So I would leave this side as 6 to the 2x and change this 216 to 6 to the third so that it has the same base. Now, once it has the same base, you can cancel the bases. So cancel out those 6's once they get to be the same base and set your exponents equal. 2x equals 3. And then divide both sides by 2. And you get x equals 3/2.
They want us to leave it like that in fraction form?
Yes.
Okay.
But I will go in and check your test just to make sure. If you put 1 and 1.5 on that one, I'm going to count it because that's the correct answer. But I'll have to go in and check just to make sure, because I think it says down underneath the bottom of the answer, it says leave your answer in fraction form. So I think the directions tell you it wants fraction.
Okay.
And this is a solve problem. And you have to ask yourself, can I raise 3 to some power to get 5? The answer is no. So if it's no, then you log both sides. Now, if it was an E, I would ln both sides. But you can ln both sides, as Luke found out when he was doing his homework. But most of the time, if it's a number, we log both sides. So we do log of 3 to the x equals log of 5. And then we bring this x in the front. So we have x log 3 equals log 5. You want to solve it for x, so you divide log 3 out. And then you get your calculator and you put log 5 divided by log 3, and you get your answer. 1.4650. Notice it's 50 because of that 49 has a 7 behind it. So it goes to 50. Any questions on that? Okay, let's do 24. 24 says solve for t, and it gives you an e this time, negative 0.32t equals 0.67. So this time, instead of logging both sides, because this is an e base, then what I want to do is ln both sides. So ln both sides. ln e to the negative 0.32t equals ln 0.67. Now bring your exponent into the front using that product rule. And ln e, remember, equals to 1. So that thing just cancels out there because it's 1. So we're dividing both sides by negative 0.32. So I do it on my calculator. ln 0.67 divided by negative 0.32. And I get 1.2515. Any questions?
Yes. Okay, so I was trying to see if I did something wrong because I think I got an error. So ln and it's 0.67.
Did you close your
But I'm putting it
parentheses?
close parentheses, right?
Uh-huh.
Divided by
Negative. The negative is down here by the point. It's the one down at the bottom. Negative 0.3.
I think I know what I did. Now I can tell I hit minus instead of the little negative.
Yeah, if you hit the minus, that minus on the side is a connector minus between two things. It doesn't indicate a negative. So there's a difference there. And it'll give you an error. So try putting it in again and remember to use the little negative key. Good point there. I'm glad you brought that up because people do that all the time. 25, solve. 25, you need to put a star on. 6 to the x equals 2 to the x plus 2. Okay. Well, I can't move too slower, so but I can't raise it to some power to get 6. So I'm going to log both sides, log both sides. So log 6 to the x equals log 2 to the x plus 2. Now bring those exponents in the front. This side's not so hard. It's this side over here that's hard. Now be sure you put that in a parentheses there. Otherwise, you'll get messed up and you'll just have 2 log 2 and you'll go, what? I don't know what to do with that. So make sure you use a parentheses around that group up there. Make yourself a note to do that. Okay, now watch what happens on this step right here. This is x log 6 equals x log 2 plus 2 log 2. Because what I'm actually doing is taking that log 2 and multiplying it by things that are in that parentheses. Now you have to get your x's on the one side. Get x's on the left. So I'm going to subtract this x off of this side. And so I'll end up with x log 6 minus x log 2 equals 2 log 2. See, I've got my x's over here on the left, and this one doesn't have any x's on it. Now, this is another secret right here. Factor out x. So you'll have x times log 6 minus log 2 equals 2 log 2. And then you can divide out, this is just a number, log 6 minus log 2. Okay, and that's going to be x when I get it. Now you have to be really careful about putting this one in your calculator. You want all of this to be up here in the top, and you want all of this to be in the bottom. And it depends on your calculator. Some calculators will just know that it does that. Most of them do not. So what you need to do is do parentheses 2 log parentheses 2 close parentheses close parentheses. This will give you the top. Tells the calculator that what this is in parentheses is in the top. This parentheses was automatic, and you've got to close it and close it. Then divided by parentheses log 6, and 6 is going to be in the parentheses, minus log 2, and 2 is going to be in the parentheses. And you've got to put another parentheses to tell the calculator that this is the bottom, or you'll get one of those errors. So be careful when you do this problem. Keep this note handy so you'll know how many parentheses to put in there. So I have parentheses 2 log 2, close the parentheses for the log, close the parentheses for the top, divided by parentheses log 6, close the parentheses for the 6. This is the connector minus log 2, close the parentheses for the 2, close the parentheses for the bottom. Now then, you should get the right answer. And the answer is 1.2619. Okay, be sure you keep this close, because this right here is a problem. If you don't put all those parentheses in there, you'll get, what'll happen is it'll divide log 2 by log 6, and then it'll subtract the log 2 if you don't tell the calculator all of this is in the bottom. If you get desperate and you just can't do that, you can change all of these to numbers up here. And then you'd have a number here. And you can divide that number here. And you'd have a number here divided by that number, and it'll get this number. So you can change all of those log 2s and log 6s to numbers if you want to, if you get desperate. And you can't do all those parentheses. Okay? Any question on that number 25? Okay, let's do 26. Notice that we do have more on this test than we have on the others. This one has 30 something, 31 or 30 or something. So it starts out with log base 2 of 4x minus 6 equals to 1. So we've been doing those others where we log both sides, but this one starts with a log. So if it starts with exponential, you want to log both sides. If it starts with log, you want to do exponential. So we're changing to exponential. So that would be 2 to the first equals 4x minus 6 when I change that to exponential. And that sure does look a lot better than the other one does. So I add 6 to both sides, and I get 8 equals 4x. So 2 ends up with x. Okay, so see, that's not a bad problem if you just remember to change it. It starts with a log, so change it to exponential. Any questions on that number 26? Okay, 27 is a little bit tough. So let's look at 27. It says solve. And it's got log base 5 of c plus 21 minus log base 5 of c plus 5 equals log base 5 of c. That's the way it starts. So this subtraction right here, you want to change to a division problem because it was subtraction there. This is the top and this is the bottom. So I'm going to write log base 5, and on the top I'm going to put c plus 21, and on the bottom I'm going to put c plus 5 because that's what that minus does. It moves this log number down here to the bottom. Equals log base 5 of c. If log base 5 on both sides, then you can cancel the logs. So I can cancel out that log 5 and that log 5 and just put the log numbers equal. C plus 21 over C plus 5 equals to C over 1. I'm going to put over 1 because I'm going to cross multiply. So I have this way, I have 1 times C plus 21, and going this way, I have C times C plus 5. So I have C plus 21 times the 1 is not going to change it. C squared plus 5C. Okay, C squared is a quadratic, so I'm going to have to set this thing equal to 0. So subtract off the C and the 21. And we'll have 0 equals C squared plus 4C minus 21. And hopefully that will factor. Let's see, we get C plus 7 and C minus 3. You set each one of them equal to 0. You get C equal negative 7 for this one. And C equals 3 for this one. And this one right here is where you really have to watch out. You can't have a negative log number. So if I put this negative 7 into this one, I'm okay because it's positive. But if I put the negative 7 into this one or this one, I get a negative log number. So this one is called an extraneous root. And so the only answer that I have is that 3. So watch out for those negative log numbers. You can't have a negative log number. That big number there, that negative log number. You can't have it. Okay, so keep 27 close to you when you're doing the test so that you won't mess up somewhere. It'll be just like that. These numbers will be different, but you'll still cancel. You'll put them together as a division. Then after their division, and you have log 5 on both sides or log 7 or whatever the log's going to be, cancel out those logs and then cross multiply your proportion there. Set it equal to 0. Okay, 28. 28 is like that. It's a solve, and it's log base 5 of x plus 10 plus log base 5 of x minus 10 equals 3. Now look at this one. I don't have a log on this other side like I did on this one, so I'm not going to be able to cancel my logs. See, this one had a log over here too. It was log base 5 of c, but this one only has a 3. It doesn't say log base 5 of 3, so I'm not going to be able to cancel out the logs. This is plus, so that means I'm going to make this into a product. Log base 5 of x plus 10 times x minus 10 equals to 3. Okay. Now then, you're going to change this to exponential. And I'm going to take the 5 and I'm going to raise it to the 3rd power, and I'm going to set it equal to that great big log number, x plus 10, x minus 10. 5 to the 3rd is 125, but I'm going to have to see what this is. This is x squared minus 10x plus 10x minus 100. So I'm going to subtract this 125 because it's quadratic. We'll have to do something about that. So I have 0 equals x squared minus 225. So let's do the square root. We can do square root on this one. So I have 225 equals x squared. I don't have a linear term, so I can take the square root. Plus or minus the square root of 225 is going to be equal to the x. So let me see if that is a perfect square root. Yep, it's 15. So I have plus or minus 15 equals x. Now I've got two values, positive 15 and negative 15. Can I use? Yeah, I can't use the negative one because it'll make that one a negative log number. That one too. So I can't use the negative. So my answer is positive 15 equals to x. Can't use the negative.
15 equals x, that's fine, right? We don't have to put the positive inside.
Right, you don't have to put the positive. It's understood to be positive.
Okay, perfect.
Okay. All right. I think we've got two more. Let's do 29. 29 goes back to investment problems. I think I have it written out. I do. It says, suppose that $18,044 is invested at an interest rate of 5.2% per year, compounded continuously. That's a different formula. Find the exponential function that describes the annual after t years. So the continuous formula is this one. P of t equals P sub 0 e to the kt. That's continuously. So I need to know my P sub 0. My P sub 0 is what we started with. And my K in this one is the rate, 0.052. And then we just fill it in to get our formula here. P of t equals 18044 e to the 0.052 t. And that's the answer for the A part.
So they just want the function on the part one.
They just want the exponential function. When you get to B is when you're going to do the balance. You want the balance after, and then they have 1 year, 2 years, 5 years, and 10 years, like that other one did. It's just like that other problem. The only difference is this is one that compounds continuously. So we're going to put the first one there. It's going to be P of T equals 18044 times e to the 0.052 times 1. All right, so you grab your calculator. And on this one, you want to put them in there so that you can keep them. I'm going to clear that out so I can see them all as they're down there. 18044, second, and e. We'll already put the little exponent up there. 0.052 times 1. Okay, check to make sure your first one's right because you're going to go backwards and do all those others. So I get 19007.11. It tells you to do it to 2 decimal places.
Where was the E button? Can you show me one more time?
Yes, E is above the LN. If you see the LN key, the
Okay,
E
so
to
I
the
pressed
X is
second.
right above it. So if you do second and LN, it'll give you
Okay.
the E.
Okay, thank you.
Okay, now once we hit, yes?
I was going to say there's also just the regular E, which is above the division sign.
Yes, there's another one over there above the division sign. There's one in math. There was one in catalog. They're all over the place. You just got to find one of them. All right, now second and entry would give you that same problem, and you can go backwards and change that 1 to 2 and hit enter, and it will give you your second answer, which is 20021.63. Then you can do second and entry and go backwards and change your 2 to a 5. And you get 23401.81. And then do it again, second and entry, and go backwards and change your 5 to a 10. And you get 30350.51. And again, make sure you get that first one in there right, because if you do this method, all these others will be wrong if you miss that first one. C is what is the doubling time. And there's a doubling time formula. T equals ln2 over r. R is your rate. So we have ln2 divided by our rate was 0.052. And you get 13.3. It will double in 13.3 years. That's the doubling formula. Any questions on that one? Okay, number 30. Number 30 is probably the hardest one on there to understand why it works the way it does. This is one of those that gives you all this data, and it's going to be these divorced adults. It's going to be a divorced adult problem. Okay? Says that the people who are married adults are declining, and it's according to the chart. Sometimes it starts with 1950, sometimes it starts with 1960, sometimes it'll start with 1970, but this is your starting time. This is where you start. So this is your P sub 0 right over there. Okay? So the first thing that you have to do with these problems that have the data points in them is decide what kind of formula you're going to use. Because it's declining, you're going to use the decay formula. So it's got the negative K in it, not the positive K. So it's P of T equals P sub 0 e to the negative KT. And when you put the information in for 1960 and 2012, you're going to get what your K is, because this will tell you the number of years, and you've got your information for 2012 and 1960. So this is the way you want to do it. For P of T.
Is that a negative KT?
Yes, because it's declining. For your P of T, you want this last value, 41.1. For your P of 0, of course, it's 73.1, and you can see it's declined. You've got 2012 and 1960. So when you subtract those two, you get 52 for your T. So then you fill in your information. Your P of T is going to be this 41.1 that you're going to put in there.
Can you explain which one was P of 0 and P of T? I think I had missed this on Tuesday.
P of 0, 0 means your original amount is what that means. So our original starting amount was 73.1. P of T is where you're going to find some value down the list. You could have used any of these, actually. They just ask you to use 2012. But this is going to be your information for P of T, whatever this last one is. So your P of T amount is 41.1, and it happened in 2012. So you've got to figure out how many years there are between 1960 and 2012 to get your T. That'll get your T.
Okay, I get it now. Thank you.
Okay. So P of 0 is where we started. It was 73.1. The E is in our formula. The negative's in our formula. The K is what we're going to find. And we know the difference between 1960 and 2012 is 52 years. So if we can figure this one out, we're good. Now, I know starting this one, getting the information in there is one thing, but getting it started then is another thing. To get it started, your goal is to get K on one side and all of your numbers on the other. So these are just numbers right here. I can divide out that 73.1. Now, the only thing is you have to keep all the decimals on this, because if you don't, you'll lose a decimal at the end. So I'm going to divide out the 73.1, and see, that's going to leave me with this e to the negative k times 52 on that side. And over here on this other side, I'm going to get this long decimal, 0.5622435021. And that's kind of overkill. You don't really have to have that many. I just put all of them that were in the calculator. E, and I'm going to change this around to negative 52k and put my number in the front. Okay, now I want to get rid of this E. So what I want to do now is LN both sides. 0.5622435021 equals ln e to the negative 52k. Okay, so bring the 52k in front, and your ln e is going to go to 1, but I'm going to write it in there anyway, and then I'll scratch it, I'll cancel it out. So I'm writing this side down. Negative 52k, and ln e is going to go to 1. So now all I have to do is divide both sides by 52 and negative 52, and that will get my k. So I put all of that in my calculator. ln 0.56224350021 divided by -52, and I get that number right there, 0.01107. So I get 0.0111 equals to K. But now that is the answer that I have for K. The negative is in my formula. So when you see this on your system, it's going to have a blank there. It's going to have an E there. And it's going to have a blank up here and a T beside it. And the negative, I think, is already in there. If it's not, you'll have to put the negative in there because this is a decay problem. So it'll have to have a negative. And the number in front over here was 73.1. That was my piece of zero.
Would the 0.0111 be negative?
Yes, has to be negative.
Okay.
Because it's a decay problem. If it's not negative, it won't go down, it'll go up. The other half of this is the growth one, and it has a positive K. Right, now this is just the A part where you did all of that work just to get K.
Oh my God.
Okay, this is the whole thing that you wanted right there is that formula. Now then the B part's going to have you estimate the percent of adults who are married in 2015 and 2018. So let's look at that. I'm going to write this formula up here so we'll have it. 73.1 e to the negative 0.100111 t.
I can't see what you're writing. I'm sorry.
Sorry.
Okay, thank you. This is part B, or this was the answer.
This is the answer from A. Now we're going to do B. B says estimate the percent who are married in 2015. Notice that was not on our list over there. And 2018. So our initial amount was in the year 1960. So we've got to do 2015 minus 1960 and 2018 minus 1960 to get our years, our T for those years. Okay. So 15 minus 1960 is 55, I think. And 18 minus 1960 is 58. So those are our T's for those two problems. So let's do the 2015 one. That's going to be M of T equals 73.1 e to the negative, I'm going to put the 0 in there, times 55. So I take my calculator here and I do 73.1 and then I do E and I raise it to negative 0.0111 times 55. I get 39.7. Then in 2018, I do the same thing, 73.1 e to the negative 0.0111.
I didn't get that. Mine says the error. So
Yours says error?
I don't know like what I did wrong.
Hmm.
Yeah, I got an error. Like I couldn't even solve it.
Okay, do it with me. Do
That's really weird.
73.1. Did you do that?
Yeah.
Okay, now do second and the E, which is the LN key. Did it put an E to the X in there?
No, it does E with a caret.
Well, oh, it does? You don't have a box?
That's what mine does.
Okay, then you'll have to put a parentheses.
I have it under T84, so I don't know if that's why.
You'll have to put a parentheses on yours and put.
I did a close.
Did you put a parentheses on the exponent?
Error.
When it put the caret up there, did you put a parentheses?
It does the parentheses part automatically.
Okay, so then do negative 0.0111 and then times
55, and I got error.
55. Close your parentheses. Did you close your
parentheses? Yeah, and I got an error.
Real quick, instead of doing the E to the X, just do the regular E and then raise it to an exponent. That way you don't have to use parentheses and all that.
This E over here?
Yeah.
Okay, let me try it again. Yeah, my calculator doesn't even look like that. You have the newer edition than I do.
Oh, really?
So that might be like why I'm having a harder time. Because I have the you have the silver edition. I have the older one, the 84. So they're like a little different, I guess. I don't know.
Well, if you put a parentheses, you can try that other E, but you'll have to use a caret to raise your power. Does it, if you do the other
E? I was using the caret.
You were using the caret?
Okay, I got it. I got it now.
How did you get it?
It's 39.6. I don't know. The first time I typed it in, it didn't work, and it's literally the same. So I really don't know.
Okay.
I have the 84
last
too.
2 times it worked, and every time I closed the parentheses, see, so that was really weird. I don't know why I didn't get it the first time.
I just think they glitch sometimes because I have an 84 too, and I have the box, so I think they just glitch.
Well, sometimes you might put a space in there too, and if you put a space, I don't think it's going to work for you either.
Okay.
Okay, so if you do in 2018, try it with it 2018 and see if you get 38.4. Did you get 38.4?
Yes, I got that.
Good. Well, tell your calculator to act right. And
I know, it better act right when I do my test. What the
heck? I know, right? We don't have time for errors.
Right. All right. The C part of this one is, when will the percent of adults be 32%? So what you're going to do is put your 32 over here and your 73.1 and E to the negative 0.0111, and the T is what you're going to find when you do this one, because you're finding when it's going to be 32. So this is another one of those that we had like a while ago where you divide both sides by that 73.1, and sometimes it's just hard to start these. 0.4377564979. Then you bring that exponent to the front because you're going to LN both sides. Bringing that exponent to the front using that product rule. And remember, your LNE is going to go to 1. So then your last step is going to be to divide both sides by that decimal. So you get T is 74. Now you have to watch your question. On the test, this one's not going to say how long, it's going to say in which year. So you are not finished here. You've got to decide in which year will it be at 32%. So you've got to know what your initial year was. Go back to your little sheet you had. What was our initial year where we started all this?
1960.
1960. So 74 years later from 1960 is when this is going to happen. So what year is that? (2034) 2034 is when that's going to happen. So what's your question on this one? Put yourself a star or underline this or something, because I know it on your homework. Sometimes they ask you what time, the time, how much time would go by. And sometimes they would ask in what year. The one on the test is going to say in which year. Okay. Any